Okay, today we're going to be looking at sequences. And we're going to look at two particular types of sequences. The first type we call arithmetic sequences. These are numbers that are put in an order in such a way that they have what's called a common difference. That if I move from one number to the next, I am adding the same thing. And so that could also be negative numbers. I could be adding a -5. A lot of students like to think of it as you're either adding or subtracting, but it's called a common difference. Then the other type of sequence is a geometric sequence, and it has something called a common ratio. And so that's where I'm multiplying one number, so I could multiply by 2 here, and if I multiply by 2 again, and I keep multiplying by 2 to keep getting the next number, that is my common ratio. Also, the ratio could end up being a fraction. It could be something like 1/3. You're multiplying by 1/3 each time, and a lot of students like to think when they're multiplying by these fractions, you're really dividing. So they like to say it has a common ratio if you're multiplying or dividing by the same thing. So let's go ahead and look at a couple of examples. This first example is a word problem. While organizing magazines at a doctor's office, Rudy put 11 magazines in the first pile. So I'm going to start writing these down. 11 magazines in the first pile, 22 magazines in the second, 44 in the third, and 88 in the fourth. So we have options of, is this arithmetic, geometric, both, or neither? So what I would suggest you do is start with the second term, and in your calculator, let's subtract from it the first term. So I'm going to have to use the decimals online. So that would be 22 minus 11. Well, that answer is 11. So that means that to get from 11 to 22, I added 11. Well, let's do 44 minus 22 and see if we get 11. So 44 minus 22, no, that gave me 22. So that means this one cannot be a arithmetic. So then we need to check it to see if it is geometric. So to check it to see if it's geometric, instead of subtracting our numbers, we are going to divide them. We're going to start with the second term and divide it by the first term and see what we get. So 22 divided by 11, well, that's 2. So that means I took 11 and multiplied it by 2 to get to 22. And let's see what 44 divided by 22 gets us. 44 divided by 22 also gets us 2. So that means I've multiplied both of these by 2. Well, 44 times 2 is 88. So since it's multiplying, it has a common ratio. This is geometric. And I worked backwards. For a lot of people, this would be easy to see that 11 times 2 is 22. 22 times 2 is 44. For some people, it's not. And then when we start getting into things that turn into fractions or ugly decimals, this is a sure way to do it. So let's look at this next one. Our options are still arithmetic, geometric, or both. Leslie put 4 beads in the first jar, 9 beads in the second jar, 16 in the third, and 25 in the fourth. So if we look, I'm going to start by subtracting. 9 minus 4 is 5, so it means I added 5 to 4 to get to 9. And I'm going to look at 16 minus 9. And so that means I added 7 to get there. Those are not the same, so it cannot be arithmetic. So let's divide and see if it's geometric. I also work backwards because if our common ratio happens to be a fraction, by working backwards we're getting that fraction. So let's do 9 divided by 4. I'll show you by typing it in decimals here. 9 divided by 4 is 2.25. And let's do 16 divided by 9. That works out to be 1.7 repeating. So that means it's not geometric. Well, if it's not arithmetic or geometric, it can't be both. So it has to be neither. Let's look at this next example. What type of sequence is this? Well, let's just start. Those numbers are getting big pretty quick, so I'm going to check for geometric first. Well, 18 divided by 3 is 6, and then let's look at 108 divided by 18 and see if that is 6. It is as well, so my common ratio is 6. So since I could do that, that means it is geometric. So you would have done 18 divided by 3 equals 6. 108 divided by 18 equals 6. So the common ratio is 6. Since it has a common ratio, it's geometric. So on the last day of school, the first student will receive 2 blue pens, the second will get 6 blue pens, the third will get 18 blue pens, and the fourth will get 54 blue pens. So if we look at this one, if I do 6 divided by 2, that is equal to 3. If I do 18 divided by 6, that is equal to 3. So it means I have a common ratio of 3. So since I have a common ratio, my answer is that this is a geometric sequence. Let's look at the next example. Hardware store ordered 41 hammers, and they ordered 59. They ordered 77 in January, then they ordered 95 in February. So it's increasing. It's not increasing super fast, so I might want to check and see if it's an arithmetic sequence first. So I'm going to do 59 minus 41, and that should give me 18. So remember, I start with the second and work backwards. So then I'm going to look at 77 minus 59 and see if I get the same number. And I do, I get 18. So that means it has a common difference that is equal to 18. So that makes this an arithmetic sequence. My next example, it's already laid out for me. So these are increasing. They're not increasing at a super fast rate. So I'm going to check for arithmetic first. So I'm going to do 112 minus 99 and see what I get. So 112 minus 99 is equal to 13. So then I'm going to try 125 minus 112 and see if I get the same thing. And I do. That is equal to 13. So since they have a common difference of 13, that means it is an arithmetic sequence. While counting chairs in the lunchroom, Sean noticed 95 chairs in the first row, 95 chairs in the second row, 95 in the third row, and 95 in the fourth row. And people's first instinct is to say that this is neither because it's the same number repeating over and over and over again. But if we look, 95 minus 95 is 0. And then if we look, this 95 minus that 95 is also 0. So it has a common difference that's equal to 0. So it could be arithmetic. But then I want to also point out here that if we do 95 divided by 95, we get 1. And then if we do this and 95 divided by that 95, we get 1. So it has a common ratio that is equal to 1. So it appears it's also geometric. So in this case, the answer is both. It's both geometric, it is both arithmetic. Then the other types of problems that you're going to incur is they give you the formula and they tell you to fill in the first 4 terms. And they tell you where to start. N is equal to 1. So this becomes a simple task of just substitution. So this first term is going to be 3 times 4 raised to the n power, but we know we're going to put in 1. So then this next term becomes 3 to the 4, and this is the second term, so that's 2. And it's going to be 3 to the 4th to the 3rd power, and this last one's going to be 3 times 4 to the 4th power. So this is where you can go to your calculator and type these in. Your scientific calculator or your calculator on your phone should be able to handle these. 3 times 4 to the 1st power is 12. 3 times 4 to the 2nd power, whoops, I typed 40, let's go back and fix that, to the 2nd power is 48. 3 times 4 raised to the 3rd power is 192, and then 3 times 4 raised to the 4th power is 768. If you're using your calculator on the line, to get the exponent, you need to hold Shift and press the number 6 key on that little caret key that's pointing up, just like on the TI-84 calculators that we use in class. So we have 12, 48, 192, and 768. So we can fill those in. So the sequence would be 12, 48, 192, and 768. Then the only other type you're going to get is where it is an arithmetic sequence. I know this is a geometric sequence based on the explicit formula, the fact that it's a power changing to get the term that makes it geometric. Whereas this one, I'm multiplying by that n instead of using it as a power. So I know this one is an arithmetic sequence. So I'm simply doing 7, and it says let's start with 1. 7 times 1 plus 1. So that first number is going to be 8. I have to do 7 times 2 plus 1. So the second number is going to be 15. I have to do 7 times 3 plus 1. So this second number, the third term is going to be 22, excuse me. And then for the last term, it's the 4th term. So that's 7 times 4 plus 1. So the 4th term should be 29. So this is our sequence based off of that formula. And so those are all the types of problems you should incur on sequences.